The notion of functional dependencies is used to define second and third normal form and the Boyce-Codd normal form, or BCNF. Functional dependencies are fundamental to the process of normalization. Functional dependency describes the relationship between attributes, like columns in a table. Functional dependency, or FD, is a set of constraints between two attributes in a relation. Functional dependency says that if two tuples have same values for attributes a1, a2, up until an, then those two tuples must have same values for attributes b1, b2, up until bn. Functional dependency is represented by an arrow sign, that is x arrow sign y, where x functionally determines y. The left-hand side attributes determine the values of attributes on the right-hand side. Armstrong's axioms. If F is a set of functional dependencies, then the closure of F, denoted as F+, is the set of all functional dependencies logically implied by F. Armstrong's axioms are a set of rules that, when applied repeatedly, generates a closure of functional dependencies. Reflexive rule. If alpha is a set of attributes and beta is subset of alpha, then alpha holds beta. Augmentation rule. If A arrow sign B holds and Y is attribute set, then AY arrow sign BY also holds. That is, adding attributes and dependencies does not change the basic dependencies. Transitivity rule. Same as transitive rule in algebra. If A arrow sign B holds and B arrow sign C holds, then A arrow sign C also holds. A arrow sign B is called as a functionally that determines B. Trivial functional dependency. Trivial. If a functional dependency FD x arrow sign y holds, where y is a subset of x, then it is called a trivial FD. Trivial FDs always hold. Non-trivial. If an FD x arrow sign y holds, where y is not a subset of x, then it is called a non-trivial FD. Completely non-trivial. If an FD x arrow sign y holds, where x intersect y equals phi, it is said to be a completely non-trivial FD. Normalization. If a database design is not perfect, it may contain anomalies, which are like a bad dream for any database administrator. Managing a database with anomalies is next to impossible. Update anomalies. If data items are scattered and are not linked to each other properly, then it could lead to strange situations. For example, when we try to update one data item, having its copies scattered over several places, a few instances get updated properly, while a few others are left with old values. Such instances leave the database in an inconsistent state. Normalization is a method to remove all these anomalies and bring the database to a consistent state.